So functional dependency. So you cannot discuss normalization, or you cannot attempt normalization unless you are well conversant with the aspect of functional dependency. Remember, we said that normalization will try to establish the relationship that exists between attributes of the same entity or attributes of the same relation. So a functional dependency describes relationship between attributes in a relation. So in other words, it tries to look out for each and every, all the attributes that you'll have in a given relation. What is the relationship? What is the kind of dependency that one attribute has over the other? So if A and B are attributes of a relation, B is functionally dependent on A. If each one value of A in R is associated with exactly one value of B in R. So here, I think through demonstrations, that is when I'll be able to really explain this. So we have, and we are assuming that these are two attributes of the same relation, attribute A and attribute B. Now, attribute, the way it is, when you see this arrow, it means that A determines B. Or you can say B is functionally dependent on A. So this arrow means something, and it is telling on the kind of relationship that exists between those two entities. So a determinant of a functional dependency refers to an attribute or group of attributes on the left-hand side of the arrow. Now, let's assume this is a table. Again, the other table staff branch that we've been using. Now, within this table, you are in position to ascertain a kind of functional dependency that exists between the different attributes. For example, we are saying that branch number determines branch address. We have said that a functional dependency is where the values, for example, the values of A, okay, we shall say that branch number is functionally dependent on branch address if the values of branch address correspond to exactly one value of branch number. So in other words, if you look at 22 Deer Road, London, the value of A should correspond to exactly one value. So when we're talking 22 Deer Road, London, so that means we should only expect to have one B005 corresponding to that. Otherwise, if we have 22 Deer Road and it has another branch number, let's say B003, then we shall say that there is no functional dependency between branch number. Rather, branch number does not determine branch address. So what you need to stick on is branch number determines branch address if one value of branch address is directly mapped onto one value of branch number. That is the aspect of functional dependency. So this is an example. When you see here staff number and position, okay, the position is functionally dependent on the staff number. Why? Because we shall only, if we say staff number, let's say S011, we shall know that staff number is either a manager, is either a reception, because that kind of staff number or staff ID cannot be given to more than two people. So you realize now staff number determines position because one value of position directly corresponds to one value of staff number. This is what we call the functional dependency. It is like here, if we have an example of a student, a registration number, and the student name, okay? Registration number determines the name, or the name is functionally dependent on the student's registration number. Why? Because one value of the name corresponds to only one value of the registration number. So whereas we can say that so in this case, you can say registration, if you have a registration number 0112X, etc., etc., it will correspond to only one name, only that name, let's say called Fred. But Fred, if you say Fred, Fred cannot determine the name cannot determine the registration number. Why? Because you can have Fred, but there are many students in the class who are called Fred, implying that they will have different registration numbers. So the name will not determine the registration number, but registration number determines the name. So that is the same thing here, that position manager, you'll find that there are many managers in that given organization. So position cannot determine the staff number, because when you say manager, it may correspond to more than one value. That means it negates the principle of functional dependency. So here we have an example of functional dependency that we can use to demonstrate functional dependency. Now, you have this teacher, course, and the text. If you look at this table, under teacher, you have Smith, Hall, and Brown. Now, let us first start with between teacher and course. You're looking for functional dependency. So between teacher and course, you ask yourself, is there a functional dependency between teacher and course? So if you look at teacher, you have a teacher Smith, okay? So when you say Smith, does it correspond to data structures only? No. When you say Smith, Smith teaches data structure and Smith teaches data management, implying, just by looking at these two, implying that the teacher cannot determine the course, because Smith corresponds to data structures and Smith corresponds to data management. So you cancel out teacher and course. And then you go to teacher and text. If you look at teacher, you have Smith with Bertram. Then you have Smith with Martin. So when we say Smith, okay, Smith corresponds to text. But when we say Bertram, Bertram corresponds to only Smith. So implying that this particular text, okay, corresponds to only one value of the teacher. When we say Bertram, we shall know it's only Smith, no one else, and that is what is showing. But when we say Smith, okay, Smith can correspond to Bertram and can correspond to Martin. So in this case, the text determines the teacher, because one value of text corresponds to exactly one value of the teacher. But the teacher, one value of the teacher can correspond to different values of the text. So implying that the text determines the teacher. Then let's go to the text and the course and ask yourself, is there a functional dependency? So when you say data structures corresponds to Bertram and data structures corresponds to Horowitz. Now, if you look at that, that means that the course cannot determine the text. However, when you say Bertram, we shall know that Bertram is the one who teaches the course data structures. When we say Martin, it's only Martin that teaches data management. When you say Hoffman, so if you look at that, that means the text determines course, because one value of text corresponds to exactly one value of the course. So text also determines the course. So if you look at this example, okay, this particular relation it suffers from update anomalies, and they're telling you that you need to rectify them. Now, when you look functional dependency, the first thing that you need to ascertain is first finding out the primary key of that relation. Finding out the primary key of that relation, because the rule is all attributes must be dependent on the primary key. So this particular table suffers from update anomalies. Why? Because there is an aspect of redundancy. Where is the redundancy? If you look at this table, you have the department number and then also you have the department name. Okay, you have the department number and then you have the department name. These two, if you have the department number in the table, it can suffice. You don't need to have the department name. Likewise, the reverse is true. So in this case, what you do is we need to ascertain the functional dependency. And after ascertaining the functional dependency, we create a new table for those for the functional dependencies that we have identified, such that we are in position to rectify the anomalies. So when we go, if I go to my, so here we are. Okay, that's the table. Really, this is the table. Okay. So we need to ascertain the functional dependencies within that table. So in this case, this is the primary key. So this primary key, the first functional dependency is the social security number determines the employee, because every employee has a social security number. Then this social security number also determines the date of birth, okay, because it is like your NIN, your national ID. Your national ID has all those details. So when I know your NIN, I will know your date of birth. Also, this SSN does determine the what? It determines the address of that individual. Still, when you look at your national ID, it has the location or place of birth. So that means if I look at that ID, I look at your NIN, I can know where you are born. So the SSN also determines the address of that employee that you have in an organization. Now, the SSN also determines the department number where that employee is working, okay? Where that employee is working. So also the SSN determines the department number. I can know your department by just looking at your SSN, because we shall know whether this person is in the networks department, whether they are in the information systems department, and the like. So now we'll bring this and then put it there. So that's the first functional dependency. So once you have that, then you can say here FD1. Then the other is between the department. You have here the department number determines the department number determines the department name, okay? It determines the things that can disturb. That's what I want. So the department number determines the department name. It also determines the department name. This thing is disturbing me a lot. The department name, and then also it determines the manager who manages that department. Okay. That is functional dependency 2. This is our FD2. So the resultant tables are you have a table called employee, and this employee has the SSN, which is the primary key. It has an employee name. It has a B date. It has an address and a D number where that particular employee, where the department where the employee is attached. So this particular, that's table 1, and this is the primary key, SSN. And then we create the other resultant table for each and every functional dependency. It's a new table that you have created. So we have another table called department. Which has the D number, which is a primary key, and then you have the D name. Then you have the D manager SSN number, like that. So in this case, this one here is your primary key. However, this one here is your foreign key, which references this department number in that particular table. So these are the resultant tables. Now these two tables are not subject to update anomalies because we have dealt with the redundancies. So these are the resultant tables. Okay, so now we go to the process of normalization. The process of normalization 1, you have got to be able, it's based on identifying the primary key, because the entire technique is about analyzing a relationship, but it's based on 2 things: the primary key and the functional dependency that exists between the attributes, like what I have just done. So it's often executed as a series of steps, and we always start with the first normal form, then we go to the second, and then the third normal form, and the other normal forms. What you need to appreciate here is the more you normalize your tables, the stronger they become, and therefore they are not susceptible to the update anomalies. So we can start off with an anomalized form. This is a table that contains 1 or more repeating groups. Okay, this table can have either, in other words, the repeating groups are looking at the multiple values that could either be a composite attribute, or they could be multi-valued attributes. So where you have a table that has either composite attribute or a multi-valued attribute, it means that that table is anomalized. Now, so So the other way you can have an anomalized table is by creating a table from a form. For example, you can have a patient form, you can have a doctor form, a patient form, you can have an online reservation form. The forms that we usually fill in, it can be a biodata form. So if you have that form, you can create a table with rows and columns out of that form. So the data that you have at that particular moment in time is anomalized data. So now we go to the first normal form. A table is in the first normal form if all attributes are atomic. Remember, we said that an atomic value or an atomic attribute is that particular attribute that have a single value that it holds. So in other words, whatever elements it has, they are not divisible. So this implies that so in the event that you have a table that either has a composite attribute or it has a multivalued attribute, then you know that that particular table is not in the first normal form. And because it's not in the first normal form, there are two things that you need to do. First, you try to remove the repeating groups by flattening the table, or you create a new table, especially if it is a multivalued attribute. So the first important thing, like we said, that in normalization, you need to identify the primary key. That should always be your number one. And then after identifying your primary key, you go into the functional dependency of the different attributes within that given relation. So first identify the primary key, and either you place each repeating group on a tuple. A tuple is a record with duplicated values such that the values are not repeating. So that process is called flattening the table. Or you can get that those attributes, especially if it's a multivalued attribute, you get the multivalued attribute and then you create a separate relation for that multivalued attribute, just like what we have been doing. So when you create a separate relation for that multivalued attribute, that means you're going to have a result. Your resultant relations are going to be two. The table for a multivalued attribute, which is going to be now an independent table, and then where we got that multivalued attribute from. Remember that the multivalued attribute takes the copy of the primary key of the previous table, and then it forms part of the primary key of the multivalued attribute to have what you call a composite primary key, but that is subject to a condition where if the attribute of the multivalued attribute cannot be duplicated, then it can stand as a primary key on its own. Otherwise, if it can be duplicated, then that is when you can concatenate both attributes to have what we call a composite primary key, just like how I explained in my previous lecture. So you have these two relations, the anomalized relation, and then you have B. B, this is what we call a repeating value. So this is a composite attribute, which is a repeating value. So what do is you create a single tuple for each and every particular repeating group. Because here research, everything says research, but there are three locations where research as a department name is found. So research is found in Belaya, research is formed in Sugarland, and research is formed in Houston. So you have to create them as separate rows. Like you see, everything doesn't change apart from the location, and then you can proceed. So now this table is in the first normal form. Why? Because the values of each of the cells is atomic, or it has a single value to it. Then we have a multivalued attribute, telephone number, which is a multivalued attribute. And we say that with the telephone number, you pull out this attribute such that you create a new table for it. And after creating a new table for it, so this is what you have here, your resultant table. You pull out this, but remember it takes a copy of the primary key, so you bring the copy of the primary key. But remember that these values were repeating groups, okay? These were repeating groups. So you bring them, the repeating groups, creating new tuples for each repeating group or a new record for each repeating group. So you will find this will have 3 records, this will have 2 records, this is 1 record, and this is 2 records, like what you see here. And then you remain also with this relation. So these 2 relations now are they are in the first normal form because the values are single atomic. Then we go to the second normal form. The second normal form is based on the concept of full functional dependency. So A and B are attributes of the same relation. For example, the student registration number and the student name are attributes of student. So we can say that B is fully functionally dependent on A. In other words, we can say that the name of the student is fully functionally dependent on the student registration number if B is functionally dependent on A, but not only the subset. So this is what you need to know. We said that there's a scenario where you have an entity that has a composite primary key. Remember, when you talk about a composite primary, we call it a primary key. Regardless of how many attributes it has, it is a primary key. In singular, a primary key. So where you have a composite primary key, in some cases, you will find that composite primary key, okay, there is a non-primary key attribute that is partially dependent on a primary key, partial dependency. So what happens here? We're saying that a second normal form, it has that relation has got to be in the first normal form. That's the first condition. And the second condition is every non-primary key attribute should be functionally dependent, fully functionally dependent on the primary key. So we are saying that the primary key, in this case, the second normal form applies to tables that have a composite primary key. So whenever you look at a table that has a composite primary key, then your next question should be, is every non-primary key attribute fully functionally dependent on the primary key? Because once you have a composite primary key, then you should look out for partial dependencies. Partial dependency means that part of the non-primary key attributes are dependent on part of the primary key. So this involves removal of the partial dependencies. Okay, so a partial dependency occurs when the primary key is made up of more than one attribute. In other words, you have a composite primary key, and there exists attributes which are non-primary key attributes that are dependent on only part of the primary key. So we remove the partial dependencies by taking the attributes that are partially dependent on the primary key to another relation by creating a new relation, and then you take the attributes plus the copy of that particular attribute that they are depending on. But that copy remains in the primary table such that it becomes a foreign key that references the new table. So what am I saying here? Let me just go straight to the point. It's a bit hard to explain this when you're not doing demonstrations. So this is a table called employee project, SSN number, project number, hours, employee name, P name, and P location. So let's try and demonstrate what I'm talking about. So you have this table here. When you look at this table, there are some functional dependencies. Okay. You have, by the way, when you're doing functional dependencies, you can use these arrows the way I have used them, or you can just create text like the text I'm going to create. But those text, they eventually become relations. So there is a functional dependency. If you look at the social security number, the social security number determines the social security number and the project number. Remember, that is a composite primary key. So when I know someone's social security number and I know their project number, I will know the hours that they have worked. Okay, so when I know this person's, and that is, remember the arrow shows that it is SSN that determines, but in this case, both SSN and, in this case, both SSN and the project number determine the hours worked. When I know someone's social security number, okay, and they know the project that they are working on, I can be in position to determine the hours that they work for. So this is functional dependency 1, FD1. Then we go to now there is a partial dependency, again, because this is the second normal form. If you look at this primary key, sorry, I hadn't described where partial dependency comes from. If you look at this primary key, SSN and project number, you realize that the project number determines the project name and the project location, but the project number alone cannot determine the employee number. In other words, by knowing the project number, it does not necessarily tell you the names of the people in that project. So implying that, but when I know the project number, I know the project name and the project location. So this project name and project location, they are non-primary key attributes. But instead of depending entirely on both the SSN and the project number, they are only depending on the project number alone. The same applies to the social security number. The social security number determines the employee name. Once I know the social security number, I will inevitably know the employee's name. So you see that employee name, which is a non-primary key attribute, is partially depending on the primary key by only depending on the social security number instead of depending on both. So that is the concept of partial dependency. You have non-primary key attributes that are partially dependent on the primary key, like what I have shown you. So what do? You start taking out those dependencies and you create new tables for them. So now the social security number, we've said that the social security number and the project number can determine the hours, okay, hours that someone has worked. The project number can determine the project name, that's the second dependency, and it can also determine the location of the project. Once I know the project number, I will know the location of that particular project. Okay, I will know the location of that particular project. That is functional dependency 2. Functional dependency 2. And then the last functional dependency is between the social security number and the employee name and the hours that they have worked. Okay, when I know the social security number, when I know the so this the social security number determines the employee. But you make sure you draw better things. Here I'm using computers. It's a bit hard for me. So, sorry, okay. We do this, Control C. That's our functional dependency 3. So what happens is we create the tables. We create the tables after creating those functional dependency. So we shall have a table called employee in brackets, where you have the employee SSN number and the employee name. That is a primary key. Then we create another table which we are going to call project in brackets. We have a P number, a project, we have a P name and the P location. P location. That's a table called project, and then we're going to have a table, the one that has that is for the functional dependency 1. That table we can call it hours worked. Hours. Can call it hours. So in this case, this it has SSN, P number, P number, and then it has hours worked. So these are the resultant tables. You have a table called project, then you have a table called hours. Okay, so this one is the primary key. So these two here, this is and this is a primary key. This as well is a primary key, but they are also acting as foreign keys to reference the other two tables. Foreign key. Yeah, so this SSN references that, and there's this P number. The P project number references that. So these are the resultant tables. So now these tables, the resultant tables are not subject to updates, anomalies, and these tables are now in the second normal form. Why? Because each and every non-primary key attribute is fully functionally dependent on the primary key, not part. So there's also this demo. There's also this example where you have table 2 employee ID, employee name, gender, salary, department name, department ID, department location. We say that whenever you're given a table, you need to identify the primary key. Sometimes we are going to tell you to define the primary key for yourself. Like in this table, the primary key has not been identified, so you're supposed to identify it for yourself. But here there is some data. They are saying department ID for IT is 1 and HR is 2. So implying there is another table, there is another attribute called department ID, which is part of this table. Now, implying that department ID and employee ID are primary key. You set them as primary keys depending on a scenario, because we shall give you tables like that and tell you identify a primary key, normalize the table to the third normal form. So in this case, employee ID, department ID are the primary key. So is the table in the first normal form? Yes, it is in the first normal form, because all values are atomic. Then is it in the second normal form? No, it is not in the second normal form. Why? Because we have another attribute called department ID. And because this table has a composite primary key, you realize that department name is fully functionally dependent on department ID, but not employee ID. So that means there is a partial dependency. So what do? You pull out the attributes that are partially dependent on part of that primary key. You take them in another relation together with a copy of their determinant, and then you also remain with the other table. So for example, here this is an example. The resultant table is this. You will have a table with the department ID, department name, department head, location, because now these ones are fully functionally dependent on the department ID. And then also we have these ones that are also fully functionally dependent on the employee ID. However, department ID in this case here is not a primary key, but it is a foreign key. This is also another example of a second normal form where you have three attributes. You have customer ID, store ID, and purchase location. But these two are primary keys. Customer ID and store ID are primary key, is a primary key, but comprised of two attributes. If you look at purchase location partially depends on the store ID, but not on the customer ID. What does that mean? That for me, I can be in position as a customer, okay, if you go to buy in a particular departmental store or in a particular shop, okay, your ID, okay, does not determine where you are going to buy from or where you have bought from. That's why you see here customer ID Los Angeles, customer ID San Francisco. However, for your location, your purchase location is dependent on the store ID. When they say one, if you have a branch in Wandegeya, it is one Wandegeya, two say 3 etc. So this is also what is being displayed here. So in essence, you have store purchase ID being determined by the store ID, but not the customer ID. So you pull this out, purchase location and store ID, create a new relation, and then also customer ID. And so these are the resultant tables. So these resultant tables, in this case, store ID in store ID in a table called store, this one is this is the primary key for this particular location, but it is a foreign key in this particular table. It's a foreign key in this table, but a primary key in that table. So this is the explanation of that table there. So we go to the third normal form. The third normal form is based on the concept of transitive dependency. So you have three attributes, attribute A, B, C. So you have attribute B being dependent on A, and then you have attribute C being dependent on B. So in other words, attribute A determines B and attribute B determines A, implying that attribute A determines C, but transitively through B. So that is the kind of relationship that exists between those three attributes. And the aspect of the aspect of the third normal form is where you will have a non-primary key attribute influencing another non-primary key attribute. Remember, the concept is all non-primary key attributes have got to be fully functionally dependent on the primary key. But in the third normal form, you have a non-primary key attribute influencing another non-primary key attribute. So that is the difference between a third normal form and the second normal form. The second normal form, you have a composite primary key, but a non-primary key is dependent on part of the primary key. So a relation is in the a third normal form is a relation should be in the first normal form. It should be in the second normal form. And there are no non-primary key attributes that are transitively dependent on the primary key. So what do? You identify the primary key of the table in the second normal form. You identify functional dependencies in the relation. If there exists any transitive dependency, you take those attributes that are transitively dependent on the primary key together with a copy of the attribute that is determining it, or the copy that is the determinant, such that you create a new relation. That copy that is the determinant becomes the primary key of that new relation. Let's take an example of this table here. Okay, you have a table, book ID, genotype, and price. Book ID is the primary key. Now, if you look at this table, book ID is the primary key, but genotype is dependent on the gender ID. Okay, genotype is dependent on the gender ID. So you have the gender ID here, but gender ID is not a primary key. Both these two relations, both of them are non-primary key attribute. And then you have a scenario where a non-primary key attribute is being determined by another non-primary key attribute. That negates the rules of normal forms. The rule should be that all non-primary key attributes are fully functionally dependent on the primary key. So where we have the genotype being determined by the gender ID, yet gender ID is not the primary key, we pull out these two attributes. We take gender ID and genotype, you create a new relation for them. Gender ID in that new relation becomes the primary key. And then you remain with book ID, genotype, and the price. So in this table that has remained, we shall have book ID, gender ID, and price. These are the attributes. Okay. Unfortunately, I did not create this table, so it's going to be a little bit hard for me to create it. But what you should, let me go back here. What you should know is, I didn't create it, so it's going to be hard. But the resultant table, I'm just going to write the resultant table. The resultant table here, you're going to have the book ID. So we are going to have the table called book, which has the book ID, the gender ID, and the price of the book. And then we shall have the other table that we are going to call gender, which is the gender ID having the gender type. Gender type. So this one is the primary key. This one is a foreign key, referencing the other, referencing this one, which is also a primary key. Now these two relations are in the third normal form because you have removed the transitive dependency. Initially genotype was transitively dependent on the book ID through the gender ID. That is the transitive dependency, because gender ID is not the primary key. but genotype is dependent on the gender ID. So that is the aspect of dependence, of transitive dependency. This is also another example that probably you will try out in your free time, but I have already, I think, it has some similarity with the employee department kind of table that I worked with previously on the functional dependency. So this is an example of a table. They are telling us to normalize this table to the third normal form. We have seen what first normal form is, what second normal form is, and what the third normal form is. So they're telling us to normalize this table to the third normal form. So what you need to do is you need to ask yourself, is this table in the first normal form? If no, you normalize it to the first normal form. After normalizing it to the first normal form, you ask yourself, is it in the second normal form? Yes. If yes, if no. So in this case, if you look at that table, okay, let's go here. So if you go to that, if you look at this table, okay, this table here, it is not it's in the first normal form. Why? Because each and every particular value or each and every particular cell is single atomic, okay? Each and every particular attribute, each and every particular value of the cell is single atomic. So implying that this table is in the first normal form. But you have got to also mention that, because if you leave it, you lose marks. So what you do is you come here. This is a table called, we can call it, you can say first normal form, and then we call it student. Under that, it is the student ID. Student ID. Then we have first name, last name. First name. First name, last name. Class ID, class name. Then you have instructor ID. Instructor ID. Now that is the table in the first normal form. Then in the second normal form, you ask yourself, is that table in the second normal form? So you go to the principles of the second normal form. The principles of the second normal form are such that you should have a composite primary key. So in this case, the table has a composite primary key. But then you need to ask yourself, is every non-primary key attribute fully functionally dependent on the primary key? I don't think so. So if you look at, for example, class ID, okay? Class ID depends on the instructor ID, but it does not depend on the student ID. So that shows that there is a partial dependency, because class ID is depending on the instructor ID, but it's not depending on the student ID. Likewise, you see first name and last name, they are partially dependent on the student ID. They are dependent on the student ID, but they are not dependent on the instructor ID, which is part of the primary key. So you'll find that there are so many non-primary key attributes that are dependent on part of the primary key. So implying that this table is not in the second normal form, even though it was in the first normal form. So we go back here and we create the, so we deal with these partial dependencies by pulling out the attributes that this so in this case we have the attributes that are dependent on the primary key. You pull them out together with the copy that they are depending on, and then we create another. We can create another relation that we are going to call class, and then class has the class ID, class name, and the class and the instructor ID. Control C and Control V. Okay, and then we're going to have another table which we shall call student class. Because we have this as a primary key here, then we have this as the primary key there. Okay, but then this is the primary key here. This one here is the primary key, but then we have these two tables have to communicate to each other, so implying we have this Control C, Control V, which is also a foreign key, and then we have this Control C, Control V, which is also a foreign key. Okay, so that is, now these tables are in the second normal form because each of the non-primary key attributes are fully functionally dependent on the primary key. So now they've told us to normalize the table up to the third normal form, and then you ask yourself, are these tables that we have created in the second normal form? Because remember, the rule of the third normal form is a table should be in the first normal form, it should be in the second normal form, and there shouldn't be any transitive dependency. So when you look at these tables, okay, are they in the third normal form? So table student is the one you first start with. Is it in the third normal form? Yes, it is in the third normal form. Why? Because we don't have any transitive dependency. We don't have, you copy them there, we don't have any non-primary key attribute that is dependent on another non-primary key attribute. So that table student is in the third normal form. What about the table called class? The table called class is not in the second normal form. Why? Because this table has the class name that is dependent on the class ID, and yet class ID is not a primary key. So there is a transitive dependency between class name and instructor ID through the class ID, because class name is depending on the class ID, and yet class ID is not a primary key. What do? You remove that dependency. So in this case, there's going to be this table, the first table that is going to be created that deals with the dependency, and then the second table, this one is the primary key now because it's determining class name. And then we're going to have another table that we are going to call instructor. And this table instructor is going to have the class ID and the instructor ID. Class ID is going to be a foreign key referencing the other. And then, is this one in the third normal form? Yes, it is already in the third normal form, that table. So you come and you post it here. So student ID is a foreign key referencing that. Student instructor ID is a foreign key referencing that. Class ID is a foreign key referencing class ID. So now these tables are in the third normal form. So we can comfortably say that that table has been normalized up to the third normal form. Okay, it has been normalized up to the third normal form, and then now we are comfortable that those tables are not going to be subject to update anomalies. So that is what I had for you today. Okay, you can, there are other examples here. Okay, examples of normalization that you can, there's this table that you can try to normalize up to the third normal form. There is also that table that you can try to normalize up to the third normal form. There is this form I was talking about, generating a table in unnormalized form using a form. Now if you look at this form, this is unnormalized data. You can create tables out of that and normalize them to the third normal form. So that is what I had for you today. Okay, please have yourself a good morning. Bye bye.